All right, here I'm in the third part, part 3. Hopefully you had a chance to graph this beautiful triangle. Looks a little something like that. It's not a bad drawing, but it is, a drawing of triangle bad. Looking carefully at that, hopefully you can look at that and go, hey, wait a minute, I think that thing might be isosceles. A little bit of calculation to prove that. And again, I'm not using the word prove, I'm using the word justify here. Same thing, synonym for that. You could calculate this length and calculate this length and prove that those two sides are the same. You could just count this one, 1, 2, 3, 4, 5, 6, 7, 8. That's 8 units long. Certainly 8 is not equal to these two. You know it's not going to be equilateral, but you could prove it's isosceles. So, to prove, to show you got congruent lengths on here, you got to find lengths. BA is up 4 and over 4. Square those and add those. I think you end up with 32. And of course, the square root of 32 can simplify to 4 add 2. Do the exact same thing for BD, and you should have gotten the same length for BD. So bingo, you get 2 congruent sides. So there's my calculation portion of this. I've got to have words that go with that. I could then say it's isosceles because 2 of the sides are equal, and the third one, I even included that there, was different. Now, average student would go on to the next problem. I've only classified based on sides. You should also be able to classify based on angles. You should be able to notice this slope is very nice here, and this slope is very nice here. Slope of this line is -1. Slope of this line is +1. Those are at a very specific angle. You could prove that B is a right angle. You could also find angle A and angle D without trigonometry here. You could show those are 45, 45, and 90 because you know something about a 1-to-1 slope. It's going down 1 over 1, down 1 over 1. You do that by showing that these are perpendicular slopes to create a right angle there. So you show that those slopes are -1 and +1. Again, with slope, I'm not showing the calculation because you've been doing slope for so many years. If I didn't have the graph, I would show that calculation. But there it is. So I've got calculations with some words. I've got some computations with some words to support, to prove or justify or support an idea. Whoops. I don't like that those all came up at once on here, but you got this example 3. Kind of a good one. You've got 3 points given. I don't want you to pull out graph paper and do this. Do not depend on graph paper to get your answers. That's sort of a, I don't want to say it this way, but like a middle school way of approaching things is to always have a graph to count numbers. In real math, the numbers don't work out to be integers, and you can't depend on the graph to just count boxes. You have to do this with calculations. So I'm trying to get you into that by showing you some of these sketches here. Just sketch where 1,4 would be, sketch where 10,7 would be, sketch where 9,2 would be. Would it be easier with graph paper? Yes. But we're trying to bridge you into something harder eventually, to not have you depend on graph paper. Depend on the math, not just the visual. And the end goal of this, maybe pause this and graph it and come back to this. The end goal is to find where Q is, find the 4th point to make a quad, QUAD, and it doesn't have to go in that order. I didn't give you a specific letter on her. There's various locations where Q could be. You'll see on this possible scenario here, I think I graphed these right. A was up here, the furthest away from the origin. U was the next closest to the origin, and then D was the closest to the origin. Q could be here. You could have something like this, little parallelogram going that way. That's a possibility. How would you find that? How would you justify that? Most of you would probably do something savvy with slopes on here. You could find the slope of, this is one way to do it, find the slope of DA, which is up 3 and over 9, using my calculations here. From D to A, I'm going, oh, wait a minute, it's like 8, isn't it? I think I did that wrong. Holy cow, I did that one wrong. From 4 to 2 is 2 away. No, I didn't. I think I did. Yeah, from D to A. That's over 3, and that's up 3. Holy cow, yeah, 9 and 3. I did that right. Okay, just tricked myself. Looking at too many coordinates on there. And you can use that slope, because that slope should be parallel with this slope, and that distance technically you're using also should be the same as this one. So you can go down 3 and over 9. Now you don't want to use the reduced value because it won't get you all the way over here. I believe if you do that, from U, if you go down 3 and over 9, if I go down 3, that puts me as -1. If I go over 9, it puts me at 0. There should be a point there at 0, -1. Now, typically, there's somebody in the class who goes, no, 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 that's not where Q is. Q could be way the heck out here in right field. And I'd go, yeah, you're right, Dylan. It could be out there in right field. That's a possibility. Good thinking, Dylan. This is another possible answer. This is not the only answer, but it does say to find all possible locations. So if I were to use this slope of dA again, I could go this direction. Or I could use the slope of du and go that direction. You can do either one. You know, you've got opposite slopes that are parallel. That's a possibility. On this one, I used du. I went down 2 and over 8, just using my numbers here for d and u. Down 2 and over 8. Repeat that again. If I go down 2 and over 8 from A, it should give you a location for Q. So if you haven't done that yet, try it. Check your answer in a moment. I believe you end up with 18.5. So be off a graph, which is why we don't want to depend on a huge sheet of graph paper to find these. Otherwise, you're limited to the grid, the size of your grid, and the size of the piece of paper you have. And I don't want you to tape together 3 sheets of paper to get an answer that could be found pretty easy numerically. Somebody in the room is going, no, 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 you missed it. There's a third choice that's over here. You could have the shape something like this, where du is parallel with QA this way. In other words, there's always going to be 3 possibilities. Either Q is opposite of A, Q could be opposite of D, or Q could be opposite of U. It's going to be opposite of one of these 3 to create this quadrilateral, create this parallelogram. Same process. See if you got the last value of Q. And I'll show you one method I use to get it in a moment. So I believe that last one should be at 2.9. I use the slope of du. I could have used the slope of AU instead. Either one will get you hopefully the same answer. Hopefully all 3 of those agree with your answers. All right, got 2 examples left. This is not on your paper, but I want you to try this as well. You know, 2 different, same question, but worded in 2 different ways. I'll be back in a minute in the last part of this.